Biobased Backbone. Towards a sustainable, economically resilient and more beautiful Dutch-Belgian delta in 10 minutes. In northwestern Europe, at the confluence of the rivers Rhine, Meuse and Scheldt, a vast delta was formed on the coast of the North Sea. Behind elongated sand ridges, an archipelago emerged between rivers and sea arms. The frequent flooding of the land made the soil fertile and good for agriculture. Because of the strategic position, cities thrive through trading, fishing and shipbuilding. Like in most world delta regions, the economic potential came with the risks and challenges of high water. So the land was secured by dikes and reclaimed to protect the area's growing economy, its cities, ports, agriculture and industry. After a major flood in 1953, the delta works were built to protect a large part of the delta against the sea. Economy of scale shaped the agricultural landscape. Since Napoleon designated the delta in the 1800s as the European centre of sugar agro-industry, sugar beets and potatoes became the dominant food crops. With deep seaports in Rotterdam, Antwerp and Ghent and highly navigable rivers, the Dutch-Belgian delta became even more important as a transit area for oil and goods. With an extensive network of roads and railways, it is the undisputed logistic gateway to a large part of Europe, offering many different means of transport in all directions. An underground system of pipelines for fluids and gas completes the multimodal network. The abundance of natural gas in the Netherlands made it possible to grow native and exotic fruits and vegetables all year round. This has resulted in the biggest concentration of greenhouses in the world. As oil became a major driver in the world economy, Rotterdam developed into an important oil hub for transport and processing. About half of all crude oil that enters the Dutch port is passed on to the petrochemical industry abroad. The other half is processed in oil refineries in the Rotterdam port area. The major part of this oil is refined into derivatives used for transport fuels. A much smaller part is refined into chemicals and materials such as solvents and plastics, which are in turn distributed to factories in the delta area and further inland. A large part of our daily goods, such as toys, paints and packaging, are produced here. Thanks to this fossil-based economy, the region is among the most prosperous in the world. So far, the good news. But what about the future? Already, businesses are struggling to stay competitive against upcoming markets in Asia and South America. As employment declines, once strong communities falter. And what is the ecological price to be paid? How resilient is this economy in the light of a changing world where fossil resources are becoming increasingly scarce? By processing and burning fossil fuels at, geologically speaking, a tremendous pace, we are creating an unbalanced carbon cycle. When the ancient captured carbon reacts with oxygen, an enormous extra amount of carbon dioxide is emitted into the atmosphere. A part of this carbon dioxide is being emitted by the oil processing industry, next to contaminants and particulates that cause air pollution in one of the most densely populated areas of the world. The biggest part of this refined oil is used for transport purposes, where it becomes one more source of carbon dioxide and air pollution. Yet another source of carbon dioxide are the electricity plants that turn coal into electricity. To heat buildings in the cities and to grow crops in the greenhouses, natural gas is being burnt on a large scale. This increasing CO2 concentration in the atmosphere leads to climate change, resulting in rising sea levels, peak rainfall, and an increased drainage of rivers. Ironically, in this way, climate change hits the delta the hardest. Although the delta works protect the area against rising sea levels, they complicate the free flow of river water to the sea, and so significantly disrupt the fish migrations and decrease both the health and biodiversity of local ecosystems. It's clear that the delta region is facing some big challenges related to climate change, water safety, and ecology. But how will it deal with an increasing scarcity of fossil resources, since a large part of the economy and the systems supporting daily life still depend on it? Is the region resilient enough for such a major and fundamental change? The Delta region has a lot of potential to make a successful transition from fossil to bio-based and renewable resources. But clear choices and investments have to be made in the short term. Luckily, the Delta area is blessed with several locally available renewable resources. The wind close to the sea is strong, and a significant part of the electricity demand can be harvested by windmills on both land and water. The estuaries in the Delta are perfect for harvesting energy released in the process of osmosis. The amount of sun hours is highest close to the open water. Covering rooftops in cities and industrial parks with photovoltaic cells provides another source of renewable energy. By connecting the urban heating network to the existing petrochemical industry and the power plants, waste heat, now being dumped in the rivers, can be used to heat the cities and the greenhouses. Geothermal wells can be added to what will become a smart thermal grid, replacing the need to use fossil-based resources. But what about the production of plastics, clothes, detergents and medicines we use in our daily life? They are now practically all produced from oil derivatives. Can we substitute oil for other, more sustainable resources? The answer is yes, and fortunately, these resources are abundant in the Delta area. Instead of using biomass that was created millions of years ago, newly grown biomass can also be used directly. Technology is being developed to unravel biomass into fibres and green building blocks that serve as raw material for the production industry. This process releases carbon dioxide from recently captured carbon, which means the balance in the atmosphere could also be restored in the long term. Because refining new biomass takes more energy than refining oil, the energy transition is a necessity. Some companies in the Delta region already feel the urgency to phase out fossil fuels and are investigating the possibilities of using organic waste from food production as biomass for green refinery. In this way, growing biomass doesn't compete with food production and has a better chance of becoming economically viable. The sugar beet, for instance, is a good example of a crop that can be used for much more than raw sugar alone. At the harvest, the beet is defoliated and headed. During the annual beet campaign, all the beets are transported to the sugar factory, while the leaves stay behind and are used to fertilize the land. The sugar beet goes through a process of washing and centrifugation to obtain sugar crystals. Residual products of this process, like heat and carbon dioxide, are used in adjacent greenhouses to grow crops. Beet pulp is used as food for livestock, but also digested into biogas. The next step is to extract valuable resources from this beet pulp before it gets digested in the biogas plant. But this is not just the story of the sugar beet. All kinds of organic waste from local agricultural fields, orchards and greenhouses can be refined. This also applies to the maintenance waste from the nature reserves of the region. Even filtering manure for phosphates and other valuable minerals can also be an option with new technologies. If you look at it this way, the region turns out to be a vast mining area full of valuable resources. And the good thing is, this mine renews itself every season. The potential of organic waste could trigger farmers to rethink their current position as a supplier of crops for the food industry. They could be suppliers of biomass as well. With a local small-scale biorefinery, they could even become direct suppliers of green building blocks for the surrounding industry. This could create alternative business models for a new generation of farmers. This process of valorizing organic waste into green building blocks is the essence of a bio-based economy where agro meets chemistry. The demands for biomass will also probably trigger the cultivation of the types of crops that are more effective for the production of biomass, like elephant grass and flax, willow and algae. Maybe even salt-tolerant crops like spelt, samphire and sea lavender could be reintroduced and antioxidant dune plants could bloom. Fish farms on both land and water and aquatic crops along the former water defence line supply protein. Or large underwater seaweed forests that also serve as a shelter for fish and as a paradise for divers. A growing demand for cellulose may change the current monotonous agricultural landscape into a scenic landscape with beautiful alder avenues. The bio-based delta could become a picking garden for the bio-based economy with a growing recreational and touristic potential. But also cities generate enormous amounts of biomass on a daily basis, produced by millions of people. This biomass is conceived as waste and finds its way to wastewater treatments. Some of these wastewater treatments have found ways to turn the sludge into biogas and electricity for their own use. The sludge, rich in nutrients, can also be used to grow new biomass like willows and hemp. Other experiments in so-called urban mining extract valuable components that can be used as green building blocks. It gets even more interesting when households in the Delta area shred their green waste and make profit out of it. This pulp can then be transported through the sewage system to the wastewater treatment plants during the night, when the system is underused. Here, the green residue can also be refined into green building blocks. In this way, gradually all sewage treatment plants become small-scale biorefineries of organic waste. Farmer or citizen, everybody in the bio-based delta is going to be a supplier of biomass. By using the underused sewage system and the waterways of the delta, the urban and agricultural biomass is collected at biorefineries where it is processed and valorized. Existing oil and gas pipelines will be converted for the transportation of green components. Slowly but surely, a bio-based backbone emerges, where biomass and other resources are being exchanged, growing into a robust, efficient and sustainable metabolic system on a regional scale. This new dynamic creates competitive conditions and business opportunities for new, innovative companies. The already available expertise in intensive agriculture, combined with the knowledge of chemical cracking, offers the Delta a leading position in the transition towards a bio-based economy. By reinventing its own system, the Delta will become the centre of knowledge and expertise regarding the bio-based economy, exporting innovative technology to places all over the world. The Delta landscape will transform into a living lab, and quality of life will improve with a sustainable balance between technology and nature. Right now, we are at a crossroads. Are we capable of investing seriously in an inevitable greener future? Will the Dutch-Belgian Delta be leading the transition towards a future without oil? For the well-being of next generations, we have to join forces, use our knowledge, our infrastructure, and all the resources at our disposal to make this happen.